Hi everyone, it's very nice to be here in this beautiful city and for the first time at OSMC. Today I'm here with Johannes. We are both engineering managers at SUSE, and apart from that we are also developers, and we are leading the development of monitoring features at SUSE. And today we are going to talk to you about how you can automate the configuration of monitoring on large infrastructures in an easier way with Uyuni. And I'll start by framing the problem. So, as most of you probably know, managing infrastructures is never easy. Especially on large data centers, you have a lot of machines to deal with, different operating systems, different stacks. You have many times mixes of on-premise infrastructure and cloud infrastructure. And in most enterprise environments, you also have requirements about security and compliance that are not always easy to deal with. And this is where Uyuni can help. So Uyuni is not only a monitoring tool, it does more than that, although today our focus is going to be around the monitoring part. But as an introduction, it also allows you to do things like patch management, package management. You can do mass deployments of patches and packages. You can do this in a consistent and repeatable way, so you can manage your whole infrastructure inside this tool. And before we move forward, I want you to know a bit of history about how it all started. So, Johannes.
Okay, yeah, that's my turn. So as João mentioned, the both of us, we are working at SUSE on open source projects. One of them is Uyuni, and I'm now here to tell you a little bit how it came to Uyuni. So the origins of Uyuni are in a project that's called Spacewalk. Spacewalk was developed by Red Hat and published around 2008, so it's quite old stuff. They used it as an upstream community project for their satellite products, so up until satellite 5 at least. So it's an open source systems management solution with all the features like inventory, patch installations. It has a UI and also it has an API. So basically it's a web interface for managing your data center. And back then when they published it, it supported those distributions like Fedora, CentOS, and Debian. So in 2011, when I joined SUSE, they were about to make a product based on this open source project, based on Spacewalk. That product is called SUSE Manager, and SUSE adopted Spacewalk to make a product out of it, so that we can have, so that there's an open source community that we can contribute back to when making a product. So first work that was done, of course, was to make Spacewalk work with all the SUSE distributions as well, which is not too difficult because it's also RPM based, of course. So at some point, a couple of years later, Red Hat decided to go a different way when they made Satellite 6. So Satellite 6 was supposed to be built on different technologies, and we didn't really want to follow that road. So we believed that the Spacewalk code base is not a bad one. Yes, we wanted modernization, but we wanted to modernize the existing code base because we believed in it, so, and we still do. So Spacewalk at some point entered some kind of maintenance mode where less developers were working on it. So while we were doing modernizations with a team of more than 10 developers at that time, it was not really easy to contribute back to the project because they were lacking the manpower to accept our patches. More modern libraries also needs more packaging, etc., etc. So, in the end, this was leading to a decision on our side to fork the project, like to fork Spacewalk and do our own thing. So, why Uyuni? So, Uyuni is the name of our own fork of Spacewalk. So why Uyuni? Who would come up with such a name? I mean, it's a cool name, but Uyuni is the name of a salt desert, like a salt flat, the world's largest salt flat. It's in Bolivia. It looks like this. And why would we name our project like this? is because, meanwhile, it's based on Salt. So, as I mentioned, we wanted to do a lot of modernizations to the code base, and one of them was basically to replace the backend with something better than it was before in order to allow better configuration management. And our decision was to do that with Salt. So what is Salt? Maybe you might know Salt, but Salt is an open source software, of course. And it is there to help you with configuration management and also with remote task execution. I mentioned those different approaches because that is one of the reasons why it was so good for us to be used in Uyuni. Because on the one hand, we want to allow users to tell Uyuni to, okay, just install me this software right now on that server and execute it immediately. But on the other hand, we wanted to allow people to do more advanced descriptive configuration management by, in a way like, okay, I want to describe the state of my system, and then I apply the state, and Uyuni makes sure that system is compliant to the defined state. So basically, Salt allows us both of this. So you can run a remote command, you can run a script on 10 systems at the same time, or you can describe the state of your systems and just apply this every night to make sure the systems are compliant. Yeah. Apart from that, it's Python-based, so where you manage systems only need Python, basically, in order to run Salt. Typically, Salt works in a minion master way. That means there's one Salt master, and all the managed systems are the minions. Those typically require to run an agent in Python. I say typically because in Salt you have also the option to use SSH to connect to those minions from the master. It's called Salt SSH. So in Uyuni, we support both of these transport mechanisms, so to speak. But the advantage of the minion master approach is that the connection is initiated by the minions. So the master does not need to open network connections to all the systems at the same time, while rather the minions connect back to the master. So 0MQ is used as the default transport mechanism, but also SSH is possible, as mentioned. Apart from that, it's based on an event-driven architecture, so that supports automation. Means, okay, whenever the result comes back from one of the systems, like we installed a package, we want to know did it work or not, we can automatically react to that. So in the end, Salt seemed to be scalable enough for our use cases, because we also have customers requesting things like, okay, will it work with large environments? Can I manage 10,000 systems maybe? So we believed in that. Salt is extensible and customizable. I mean that we can easily write our own stuff in Python. There's a whole lot of available modules for all kinds of things already from the community. But in the end, you also want to do your own stuff. So it's easily customizable, and that's why it was a good decision for us to replace existing Spacewalk backend. So here you can see again those two concepts that I mentioned. So this is just this is a minion master setup, how it would look like. So Salt in general supports not only Linux, but also anything else. You can even manage Windows, OS X with it, but our focus is on Linux, of course, because we're open source company and enterprise Linux company. So our focus is on Linux, of course, but here on the left hand, you could easily run this command on your master, and it would give you disk usage from all the connected minions, while you could, of course, change this expression to something more to match only a set of your systems. While on the right-hand side, you see the more descriptive approach that I described before, so-called Salt states. You can define the state of your systems as Salt states, which is usually SLS files. So a simple state would, for example, say, okay, Vim should be installed, or Apache should be installed and the service should be running. Index.html should be deployed to some place on the file system, and so on. So this is all very customizable to your needs. So you can just write the states that you want for your systems. But on the other hand, on top of this concept of states, There's also so-called formulas, which means predefined states that can be shipped as packages. So you could imagine that someone could prepare a state to set up a monitoring environment, package it and ship it to you, and you can just install it and run it, for example, from Uyuni. So in Uyuni, we have a nice framework on top of these formulas because those states are also configurable with data. So you might want to configure those states with data. And in Uyuni, we have UIs to do exactly that, and that we will show you later. Okay, so summarizing, what do we have? Uyuni is a fork of Spacewalk. We have a new backend that's based on Salt. We also modernized code base in other aspects, for example, on the front-end side, but also, meanwhile, of course, there's Python 3, recent JDK version. We introduced new features that was not possible before, working with the upstream community of Spacewalk, like content lifecycle management. That means you can, your vendor channels can be staged. You can create stages as you want them, like dev, test, production, and assign your systems accordingly. There's features to build container images and to track them in your Kubernetes cluster. So, for instance, Uyuni could tell you, okay, you have a container image here, but there's a security patch available. It is time to rebuild your image and redeploy it. There's improved virtualization management, meanwhile. So that's also based on Salt, meanwhile. So you can see for virtualization hosts, you can see what VMs are running there. You can restart them. You can create new VMs and so on. Yeah, and last but not least, we also, meanwhile, provide automation for monitoring based on Prometheus and Grafana. And the history of that is that Spacewalk originally contained some custom monitoring code that was based on probes that could be executed on the systems, but it was not very, those features were not very nice. Not many of our customers were using them. Even in the community, the monitoring in Spacewalk was not very popular. So at some point, in agreement with the Spacewalk upstream, I think in 2015, we decided to throw this away from the code base and instead to do some more lightweight integration with an existing monitoring software. And now finally, with this formulas framework and all the Salt backend, we believe that Uyuni is the perfect platform to provision monitoring in your environment, because that's exactly what Salt states and those formulas are good for. And yeah, from here, João will tell you more about why Prometheus is a good choice.
Okay, so a quick introduction about the metrics ecosystem in Prometheus and Grafana for who might not be aware of this. Just a basic introduction on those concepts. So we got started with metrics because there are the most important source of information for finding problems, for understanding how your infrastructure is behaving. So apart from logs and from distributed tracing, it's one of the pillars of observability, and we picked as the first part to work on monitoring because of that. So it can be used to tell you how good you look to your customers or to your internal customers in case you are not software as a service company. It can help you find the right place to look into the logs. It can give you insights on all things and how they are behaving. Well, Prometheus, it's a quite popular tool nowadays, but it started small, originally at SoundCloud. As opposed to Singa, it does the data collection via a pull model. This has upsides and downsides. The most known good side is scalability. It tends to perform very well on large infrastructures. You can also configure Prometheus to use service discovery. This is something we are going to show on our demo later, how this can be used to automate your configuration. And the metrics in Prometheus are very simple. As you can see here, there is a name, labels, which you can customize, a timestamp, and a value, which is always a float number. So a metric is always a measurement of something. Exposing metrics in Prometheus in the ideal way should be done via instrumentation on your own applications. This is not always possible, so many times you have to use what we call the exporters. which are tools that you install on your systems and that connect to your running services. They give you insights about your hardware, about your operating system, and about your application stack. There are dozens of exporters available upstream. You'll find the exporter you need there. If you don't, it's also quite easy to build your own exporter. You can do that on almost any language. Even a bash script can be used to build a simple exporter. You just need to use that metric format and expose that on an HTTP endpoint, and that's it. Querying metrics is also one of the powerful aspects of Prometheus, mainly due to this query language, PromQL, which is a functional language. It's quite powerful to work with time series databases. It provides you building blocks for doing almost anything you can imagine. Obviously, regex matching, it allows you to do things like the ones we see here, understand how metrics behave over time, and it's used everywhere on all the interactions with Prometheus. So if you design some panels in Grafana, you'll use it. If you define alerts, you'll use it. So it's one of the fundamental blocks of Prometheus. Alerts are also built in Prometheus via Alert Manager. This is usually shipped as a separate package, but it's part of the Prometheus offer. It does everything you need about alerting, routing, duplication, grouping, etc. It integrates with quite a few known ops tools. And it has this client tool that you can use in case you want to customize how to handle your alerts. So it's quite flexible. And Grafana, it's super popular nowadays. It's going to be even more popular since they recently got a very nice funding round. And hopefully they will increase their investment on the open source product. Let's hope that happens. So it's used many places as front end for metrics. It works with Prometheus, but also with many other backends. You can connect it to SQL databases. You can connect it to InfluxDB, which is also a popular option. So it's really flexible and fully customizable. So you already have a lot of options on the pre-shipped panels. You can build your own, and you have a collection of dashboards upstream that serve a lot of use cases already. Then comes the question, how to get started. If you are new to all this, you might ask, which components do you need? How do you configure Prometheus and Grafana to work together? How do you expose metrics on your systems? How do you configure things? How do you get started with building dashboards? What should you put there? And especially when it's at scale, it becomes particularly challenging. So on a data center with thousands of machines, different operating systems, VMs mixed with containers, thousands, sometimes hundreds of thousands of metrics coming from different sources, you'll definitely want to automate this. You don't want to be tweaking configuration manually every time you want to add a new group of machines or change your application stack on that group. And that's where Uni can help. Right, Johannes?
Yes. So here we can see a very simple example. So yeah, of course you can do all that manually, like setting up Prometheus in Grafana and run the node exporter. But in this picture, you see basically very simple how it looks like. So down here is the OUD server. And by applying salt states via formulas, we can, on the right-hand side, so those are two managed systems, so we have all the information about the managed systems. We can access them from Uyuni. We can run anything there we want. We can install software and configure software especially. So why not just let Uyuni set up a Prometheus server, running Prometheus and Grafana on one machine, and the node exporter on the other machine. Because this is the machine that we want to have monitored. So from here, we can just run a formula, configure the port that metrics should be exposed. And on top of that, we have implemented some custom service discovery to basically discover the monitored systems from Uyuni. So while this is still a work in progress, we have a working patch, and we are already shipping it, but we are still pending to upstream it to Prometheus community. But that's on our to-do list at the moment. So it's just not ready yet. But in the end, Prometheus by itself will find out the configuration of the monitored systems and will configure itself based on the information it gets from the Uyuni server via the API. So how are we going to set up the monitoring environment? Also in the upcoming demo. So we will provision and configure Prometheus and Grafana on one of the managed systems. There's also pre-built dashboards for Grafana that can be deployed together with the provisioning. But of course, you can customize those as much as you want. Exporters on managed clients are enabled also via a separate formula we will show you. And for supporting larger scales, it's possible to group systems together and create common monitoring configurations. So you can have a group of, let's say, web servers or databases, and they might want to run different exporters. You might want to have Apache exporter on one group, Postgres exporter on the other group, and all that is supported by Uyuni. Service discovery, as mentioned before, so there's no need to manually configure the Prometheus server in this scenario because there's service discovery that will figure it out by itself. And last but not least, it's reproducible. So in case you just want another monitoring server, you can just apply your states to another managed system and reproduce your environment. Okay, and from here, we would now try to demo this. So let's see how it goes. Yeah, let's just go and see how it goes. Okay, so we have Uyuni here. That's I'm just going to show you some of the basic features and then pass it back to João for the monitoring setup. So this is basically how the login page looks like. So as we mentioned before, there's a lot of features in Uyuni. Monitoring is not our main business, you know. So we do data center management, and monitoring is, of course, an important part of it. And that's also why we are working on monitoring, but we have a lot of other things here in Uyuni as well, and we cannot go through all of the features right now. So I will just show you some of the basic things and those that we need for the monitoring setup. So for this environment, it's not a large scale, but it's the largest scale that we could come up with at the moment. So I think we have at least, if we look at the list of systems, we have 136 systems registered at the moment. So those have different, those are running different distributions, like we have OpenSUSE, we have a lot of CentOS here, but I think we also have Ubuntu somewhere down in the list. So just to show you that there's different, here, Ubuntu 18, yeah, we have a couple of Ubuntu 18 systems here. So let's go back to the dashboard. So let's look at one of the critical systems. So our server for this demo has a limited capacity, so we could not really sync all the content, so only OpenSUSE systems at the moment have real patches available. So looking at this machine, for example, you can see that for this system there's 38 critical patches available, a couple of non-critical ones, package updates. You see some basic information here, but also we have all the hardware information for this VM. All is gathered via Salt on the registration, and all the software as well. So if you go here, you can see all the installed software, but also you can upgrade packages, install new packages, and those kind of things. So how would I put my system into Uyuni? So there's different ways to do that, but most easy way probably is to use the UI for that. So there's a bootstrapping UI that you can use to bootstrap your systems, to connect them with Uyuni. It's basically, in the background, what will happen. Uyuni will log in via Salt SSH and will set up the minion to connect back to the master. So basically, Uyuni server is running the Salt master, and every managed system is running the minion. And all the actions that Uyuni is doing in the background are implemented with Salt states. So here it would be enough to put your host name, SSH, port, user password, and that would do all the trick. If that is not good for you, you can also just go to that system and run the minion manually, and then accept the key on the server side with this keys UI. So this is a front end to the Salt key command, so you can deny keys, accept keys, and so on. What else can you do from this UI is, for example, running remote commands on a couple of systems. So I think there were some Metallica systems here. So let's see if we can actually find those. Sorry. Yeah, that should be fine actually, no? Or don't we have Metallica systems?
We do, yeah. Just remove the star.
Maybe remove the star.
Because there is nothing before that.
Okay, I don't know why it's not working. Maybe we can try.
Try with AC/DC.
Try with AC/DC.
It's also a nice one.
I think we need a star actually, but I'm not too familiar with this keyboard yet. Okay, so yeah, we have some AC/DC systems, 48 AC/DC systems. And if we run this ls command on those, it might take a while, but as you can see, responses are coming, and that's how it looks like. Okay, this is just an example. I want to go back to this Metallica system. Sorry. And just to quickly show you the states, there's a states tab here, and it will calculate the high state for this system. Basically, the high state is what is the combined state of all the states assigned to a single system. And here you will see what is the state in a YAML format, right? So it's not it's readable, but it's not super nice to read in this format. What is included here is especially the custom configuration that you might want to create for your systems. So if we go to the catalog on this machine, we have prepared states for setting up Apache and Postgres databases. So how does it look like for Apache, for example? So this is a simple state to set up Apache on one of the machines. So yeah, package needs to be installed, service should be running, and that's it, mostly. And similar, it looks for PostgreSQL, where it is a bit more complex because we also want to create a database and some configuration. Okay, and if I want this to be applied, to be included in the state of this system, I would just assign it with this checkbox. There is also the formulas that I mentioned before. So those are basically configurable states that we are shipping as packages. And there's also UI support. So this is the current list of formulas that we are shipping. And as you can see here below, especially there's a monitoring stack of formulas to set up all the things we need. And João will now show you how it looks like and how it works.
Thanks, Johannes. So the first thing we usually want to do is setting up our monitoring server if we are starting from scratch. I'll pick this guy here, which has a fancy name for surveillance. And I'll set up Prometheus and Grafana there. So it's already checked. Okay, so what things do I want to do? If you're familiar with Prometheus configuration, you might know some of the fields here, except this one. This is actually the configuration for the Uniserver API. So we have the credentials, just double checking if the password is okay. We have the option to enable Alert Manager service. We can deploy some alerting rules here, although on the UI you can't enter the alert rules directly here. They have to be deployed via configuration management. This is something we are working on at the moment, to have the rules directly here, so you can configure it all together. You can also add some extra scrape configurations for file-based discovery in case you want. For now, we'll just deploy a simple configuration with Prometheus. We also want Grafana there. In case of Grafana, I'll just use default settings since Prometheus is running on the same host. We have this sample dashboards here that we'll want to deploy. So the server monitoring itself, we have the Uniserver monitored, a dashboard for clients and one for PostgreSQL. There is another one for Apache that you'll see there, which is still not included here on the UI, but that is going to be deployed on that server as well. And we also want to have the monitoring server itself monitored. So we want to run node exporter there with the default configuration. Here you can change the ports in case you need. This might be relevant on some infrastructures. So let's save this. Let's apply the high state. And hopefully soon we will have our monitoring server running. Still in progress, enabling all this. Okay, in the meantime, I will show you a bit more about the configuration and what we will do next, which will be creating a group of Apache servers and Postgres servers and also enable the monitoring on those. So you can see here on this Postgres 1 that we have basic settings and a database that will be created. So I can run a load test on this database and you can see what is happening on the Postgres server in real time. So hopefully now our Prometheus is already running. Yes, it's up. Let's see what we have here. Okay, so it's all up and running. We have the monitoring server itself. We have the Uyuni server. You can notice here we added some custom labels. Since the ports are configurable, you might have situations where you want to use a different port for your node exporter or for any of the other exporters. And on most dashboards, the filtering is done by port. So dashboards assume that node exporter is on port 9100. Since that might not be the case, we added a label here called exporter, which identifies which exporter this belongs to. In case you have different exporters with the same metric names, this will allow for filtering. You also have a label for the group this system belongs to inside Uyuni, so you can then in Grafana define your dashboards based on the same grouping structure. You have a host name, since we are doing the scrape by IP address, and you have the default Prometheus fields, the job and the instance. Here we also have the server endpoints. Now let's see if Grafana is also okay. Okay, it starts. Quick look on the server. So we just started collecting metrics, so there is no history here. This is some basic information about what is running on the server. And we can already see what is happening on one of our client systems, which is the monitoring server only at this moment. So we have a basic dashboard here. This is the sample dashboard we deploy. You can customize it for your needs. And now what we want to do next is monitor more systems, right? So to add monitoring to a system, you just need to go to that system. I'll go to this ACDC one, and I will enable the node exporter there. So I want to keep the default port, nothing to be changed here. So I'll just apply the...
Yep, save it maybe.
Okay. And I will apply the high state. This guy should show up here soon. Our current service discovery is configured to poll the server every 30 seconds. Maybe in production you want to use a larger interval. So it shows up as unknown. Okay, it's already up. So we have this system here. And it's also in Grafana. Now let's do something a bit more fancy. Let's enable monitoring on a big group. So we have our test hosts group, which has 125 systems. Let's see what happens when we enable monitoring on all of them. Okay, a few more seconds. It's configuring the formulas on all the systems.
So that formula supports only 3 exporters at the moment, as you can see, but we are working on extending this list, and it's also easy to extend it because you only need to write some more salt states. And we're also looking for contributions in this regard. So if anyone needs a certain exporter there, we have a public repository where we would accept pull requests on that.
Okay, and now we just need to apply the high state on all those systems. Okay, the high state has been scheduled, so they should start showing up in Prometheus. The total list appears immediately because the service discovery identifies those systems are now monitored, then they will slowly start showing up as the node exporter gets installed and enabled on those systems. Okay, this was fast. They are all up, 126. And now, if we refresh it here, we see all our systems in Grafana. In this case, this is a very large group. You might want to have smaller groups for easier navigation in Grafana, but you can see that instantly all the systems now show up here. You can pick any of them and see what is happening there. So we just started collecting insights. There is no history still. You can see some basic information about what is going on there. Now, the next thing I would like to show you is how to monitor an application stack. And for that purpose, I'll use a group of systems that I have here. And I call them database servers. And I want this set of systems to run Postgre and to have Postgre monitor it. So what I'll do first is to assign a configuration channel to these systems so that they get configured to run Postgre. Okay, and I'll want them monitor it. So I want to enable Prometheus exporters, and I want, in this case, to have node exporter, certainly, and also Postgre exporter. The test database I have created on the configuration state is called Red Queen, so I configure the Postgre exporter to access that database. Also, the configuration was set to use password authentication instead of ident, so I need to put the IP address here for the local host. The database is also called Red Queen. I will use the default listen port. I'll save the formula, and hopefully when I apply the high state, these machines will be running PostgreSQL and will have monitoring there as well.
Maybe you can show how it looks like in the state.
Yeah, sure. Okay, so we are requesting a Postgre and PostgreSQL server to be installed, the packages to be installed, the PostgreSQL server to be running. Those are the custom files we are deploying to allow Postgre to receive connections from the outside. We are also setting up the data directory, which is standard procedure on new Postgre installation, and we are setting up a user and a database. Okay. Let's see how this goes. I'll apply the high state. Now this should be installing things on those machines, and soon those should show up here in the list of targets. Okay, we have more targets now. And as the high state application completes, we should not only have PostgreSQL running, but also having it monitored. And for that, in Grafana, we also have this dashboard that we deploy together with the Grafana configuration. Okay, we already see our servers here. Still no insights, only because this is still running.
No, it's finished, huh?
Okay, it's now finished. Okay, and it seems we start to have some insights here. Nothing is happening on this database, so let's put in some load to see what happens. I have a load generation script here somewhere. This will just generate random insert, update, and delete statements so that we can see here in a couple of seconds. Okay, we have a spike here. I'll leave this running so we can see the graphs a bit more composed a bit later. So this has only some basic information about what is happening on Postgre. It's something you can customize to your needs. And the second example I want to quickly show you is about Apache. So we might also want to set up an Apache cluster. So we have this other group here. Called our web servers, and the procedure is going to be similar. So in this case, I want to assign the Apache configuration channel to these guys. Okay, Apache 2. I want to enable the monitoring formula. So again, we want the node exporter, and we also want the Apache exporter. Here with the default settings, it will just connect to Apache. Apache needs to have mod status running for this exporter to work, which is already part of our configuration. I'll save the formula, and I'll apply the high state again. Okay, I'll show you what this high state will do here. This one is a bit simpler than the Postgre one, so it requires that Apache 2 and the example pages are installed. The example pages here is just so that if we want, we can do a curl to the Apache host and see that it's actually replying to our requests. We have mod status installed. So Salt supports managing Apache components directly. You don't need to call commands or edit configuration files. You can just do it all through Salt. And we want the service to be running. Everything seems to be okay here, so I'll apply the high state. And again, our targets should show up soon here in Prometheus. Okay, they are already here. And, okay, as you can see, we have some stuff happening on Postgre. Let's see about Apache. Okay, still no data points. It seems to be running. Let's give it a minute so that we get some data there. Some other thing you might ask is, what if I want to have my systems automatically monitored when I onboard them? That is also possible. So whenever you onboard a new system, here you can have it configured to automatically get monitoring. So let's do that. I'll go here to one of my activation keys. Activation keys is a simple concept that defines which repositories and configuration a system should get when it is on board. So I'll just go here to my CentOS key, and I'll say that, okay, it's already enabled. Yeah. So this means that all the systems that I onboard from now on will get monitoring automatically. The basic default configuration for monitoring, which includes node exporter. Okay, so let's see what happens. I'll try to create and onboard a new CentOS minion. This is a simple script that will create a KVM virtual machine and will call the Uyuni API to onboard the system. So it has the key ID here, it has the server address, it has the image we want to use. Okay.
Yeah. Usually if you already have a machine, you don't need such a script. You can just run salt minion or use the UI that I was showing before.
Exactly, this is just for automating things on the demo. Okay, it's creating the VM. In the meantime, let's see, okay, we already have something happening here on our Apache servers. I have no load generation script for this one, so there will be nothing fancy happening on the graphs, but still, you can see some basic insights on what your Apache 2 servers are doing. Okay, and now we just need to wait for this machine to complete its onboarding. The VM is created, so it's now being processed in the background, and soon we will have it on the UI. In the meantime, are there any questions you have so far?
Why did you choose Ansible, Salt instead of Ansible?
Well, there are some reasons for that, but it's mainly because of the way it works. So Ansible works via SSH, so opens all the connections from the server, which in terms of scalability might have a disadvantage over Salt. And Salt also supports access via SSH in case you want to work the other way around. So in that regard, it is more flexible. And one other reason, it's the way the states are defined, the syntax of Salt configuration itself, which we find to be a bit more appealing to use.
Yeah. And if you already have an Ansible environment, Salt even supports to run Ansible playbooks via Salt. So you could reuse your playbooks while migrating to a Salt environment. The SSH protocol for us, for our customers, is important when you want to manage systems that cannot connect to the server because they are inside a DMZ or something. So it's important for us to support SSH as a transport as well. But as João mentioned, the better way is to have the minions connecting to the master.
Okay, in the meantime, we have our new system already onboarded here. Still doing some things in the background, okay, but it's already available. And we can see here that it already has the formula enabled. So let's just add it to a group. Okay, this can go into this NSA group where our monitoring server is. And hopefully now in Grafana, if we go to the systems, it should show up there. Okay, maybe we need to wait a few more seconds for the service discovery to run. In the meantime, you can see that the web servers that we have added, they are also monitored via the node exporter, so they automatically show up on this dashboard as well as the database servers. So we have both, in the case of Apache, Apache exporter and node exporter, and in the case of Postgre exporter and node exporter as well. Okay, we see our new system is already here. Okay, and it has metrics, so we just onboarded the system and got it automatically monitored. If you don't like graphical UIs so much, all that you have seen on this demo can be done on the command line via the Uyuni API. So we have an API that supports all the operations that you do on the user interface. Yeah. So it seems all is working. Back to the slides for a wrap-up.
Yeah, that's it.
So some things that will be coming next. Support for Prometheus Federation. This comes in line with a component that we have as part of Uyuni, which is the Uyuni proxy. We recommend this to be used on very large infrastructures beyond thousands of machines. Each proxy can handle up to 2,000 systems. And our plan here is to have a Prometheus server running per proxy in a federation setups, and then a central server that collects the metrics from those proxy Prometheus servers. We also want to improve the existing automation, mainly adding more exporters and adding exporters specific for things around containers and virtualization. So cAdvisor for Docker, you might be familiar with it if you monitor containers. A libvirt exporter, which can give you insights on what is happening on your KVM hypervisor, even if you do not run Node Exporter on the systems that you have there. Kubernetes already exposes metrics, so we just need to have Prometheus configured to scrape it. And the black box exporter, if you are not familiar with it, it allows you to monitor systems from the outside in terms of responsiveness. So you can see if your services are up or down, if they are responding within your SLAs without installing anything on those systems. Alerting templates, as I mentioned, we want to have those directly on the formulas. Authentication and TLS encryption, which was already mentioned in the talk from Tim about doing all this rollout with Puppet. It's something we also want to add here. And automated firewall configuration, so that if your systems have a firewall, you deploy the exporters there and it gets automatically configured. And we are also looking forward to having some contributions, so you are all welcome to take a look at the project. And now it's time for questions.
One question regarding the formulas. Can you also add default formulas to the channels so that you don't have to do this manual stuff?
You can add it to the activation keys. So an activation key assigns a set of channels to a system, and you can also assign, in this case, entitlements for a system to be monitored. Not the whole list of formulas, but you can assign the basic monitoring to a system.
And that will take care of assigning the formula to the system with the default configuration.
Yeah, but if I've got a Postgres channel, for example, I want to add the Postgres monitoring immediately.
So I think you can assign configuration channels via activation keys as well. So you can come up with your own states that you want, so your custom states. We currently don't yet support to assign the packaged formulas, I guess, on that UI for the activation keys, but that's something we should probably do. But you can already create your custom states and assign them during the registration of the system. And that can include deployment of any exporters that you want, like monitoring exporters.
Okay, thank you. I've got a second question. I'm interested in the scrape config of how your service discovery syntax works.
Sorry, can you repeat the question?
The Prometheus configuration I would like to see.
So the Prometheus configuration, it mainly uses a custom service discovery component that would be in a way similar to how the file-based service discovery component works, for example, but instead of looking for JSON or YAML files in a directory, it connects to the UUNI API via the XML RPC API that we have, and gets the list of monitored systems from there, and via the Prometheus service discovery mechanism that it's already shipped with Prometheus, it just adds those systems there with the configuration that was set on the formulas. So it's an extension to Prometheus itself. You don't need any extra package, you just need this patched Prometheus to do it. And as Johannes mentioned earlier, it's something we are working on to upstream so that you get this on all Prometheus systems, and you just need to add the settings to the Prometheus YAML file, and you'll get the configuration up and running.
Yeah.
Thank you.
Are there any other questions? If there are none, I believe you're at the end of your talk, and like it's usual, a little question.
Thank you so much.
Thank you very much. Thank you.